Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Today on the podcast, we have the pleasure of being joined with Matthew Stewart, who is a postdoctoral researcher in the Edge Computing Lab at Harvard University. He holds a PhD and MSc in engineering sciences and data science from Harvard University. Matthew's research work is highly interdisciplinary with a focus on machine learning, autonomous machines, and embedded systems. Matthew is also a part-time blogger for Towards Data Science, a co-creator of the Harvard X TinyML courses, and a research coordinator at ML Commons. Welcome to the show today, Matthew.
Thanks, Jaden, for having me. Yeah, excited to be here.
Super excited to have you on the show. I kind of wanted to kick this off and ask you a little bit, if you could share with us a little bit about, your journey, pursuing your PhD and also kind of becoming a postdoctorate researcher at the Edge Computing Lab at Harvard. Tell us a little bit about your background and kind of what brought you here.
Yeah, so if you just see it off the bat, it looks kind of random, I'm aware. So my undergrad is in mechanical engineering, and then I did my last year abroad in Singapore at NUS, and I did my thesis. I got like last pick of theses, and I worked on like an oil and gas project, and so that got me really interested in sort of the environmental work of engineering. And then I was looking for PhDs in this area, and I found a guy who was looking for an engineer to fly drones in the Amazon, and I thought that sounds super cool, So naturally I ended up doing that. Got to do a bunch of trips there, lived in the Amazon for a few months. But then one thing I noticed about that particular field is that, I thought it would be very sort of like with science, you could have a huge impact, but it turns out that when you publish these papers, like the end goal is basically like, okay, it gets put into a climate model, or like a policymaker is going to cite you to further some agenda, but you don't really have any sort of direct impact on the field or, things like climate change as a whole. And so then I started working on like edge computing stuff because I was working with these drones and sensor systems. And I found that actually like in computer science, you tend to work directly with companies like, Meta and Google. And so you have a much stronger and more direct impact on these areas. And given that these are sort of ballooning out of control in terms of like emissions and things, actually you can have way more impact doing that than you could in the field of environmental science itself. So that's kind of the rationale of how I ended up in this area.
Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app, or go to spotify.com/podcasters to get started on your podcast today.
This episode is brought to you by Shopify. That's the sound of switching your business to Shopify, the global commerce platform that supercharges your selling. Harness the best converting checkout and same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Stop leaving sales on the table. Discover why millions trust Shopify to build, grow, and run their business. Sign up today for your $1 per month trial period at shopify.com/tech23.
Very cool. Yeah, very interesting. And that makes a lot of sense. Something I would love to kind of ask you about is, how do you integrate machine learning, autonomous machines, embedded systems kind of in your interdisciplinary research that you're doing?
Yeah, so the lab I'm in, it's run by Vijay Reddy. He's the founder of MLPerf, which is kind of like the main reason ML Commons exists. It's used by like NVIDIA and stuff to benchmark their systems. But his big thing nowadays is like tiny machine learning. And so basically that's like edge computing is just anything that's not in the cloud or data center, like HPC computing kind of thing. So things like smartphones, laptops, embedded systems. And sort of that got revolutionized maybe 5 years ago or so when people were like, hey, why don't we just, instead of, having these data, like things like Alexa, send data up to the cloud and do the processing, why don't we just do it on the device? You save so much energy because communicating is very expensive energy-wise. And there's that whole latency of, okay, it takes me several seconds to send it to the cloud and do the processing and send it back. It's way faster if I just do it here. And so that opened a whole new array of use cases of, there's certain things you can't send to the cloud, like medical data and stuff. So you have a lot more opportunities there. And then in terms of autonomous systems, they run using sensors, and TinyML works with embedded systems and sensors. So they just kind of all fit nicely into that same package. And the work that we do in the lab is very interdisciplinary. So we have some people doing robotics, so that's still edge computing. I work on like sensor systems myself, and then we have an autonomous car, a guy doing flexible electronics. So it's very sort of mix and match. Most labs are way more sort of focused on one specific area, I'd say.
Yeah.
But just because edge computing is so interdisciplinary, there's a lot of things you can do with it.
That's super cool. I should have had you do this at the very beginning, but like for the listeners, can you give a brief explanation of what edge computing is and why it's like kind of applicable and really interesting in AI right now?
Well, I kind of just did with the like cloud versus basically anything that is, so the cloud is like, centralized system. You go to a data center, so Google has these huge buildings with like thousands of servers in them. And that's where most companies host their models and stuff. When you log into like Google Docs, you're just logging into a server in one of these data centers. And we kind of say the edge is like, it's the edge of the cloud. So it's still connected to the internet, but it's like, maybe in someone's home, or it's your laptop connected to the internet. It's maybe like a sensor system. So like, the ones you have that say how much energy you've been using in your house, or like a Nest thermostat. These are all kind of edge devices because they're at the edge of the cloud. So like I was saying, like it's really energy intensive to send data to the cloud. And so if you remove that capability and you just do processing on the device, we're talking about a factor of 10 smaller energy consumption. So instead of having like a device like Alexa where you're sending queries up to the cloud and you're processing and sending a response back, if you did it on the device itself, you could have it running on a coin cell battery for a year maybe, as opposed to running it on this giant 600 watt GPU for like maybe 5 seconds and then leaving it idle for an hour. So you get it's largely like the latency benefits, the energy benefits, and I guess just sort of general privacy, security. If you're not sending things up to the cloud all the time, you don't really have that same liability. Because when you send it to the cloud, you don't know where it is, right? It could be in the US, it could ship off to another country. And for some types of data, you get in trouble if you do that.
Yeah. I think a lot of people are really excited about that whole prospect of, eventually a lot of AI models, open source models or other models like running on edge computing devices. And it's really fascinating concept that, like we're not quite there in a lot of regards, but as these models get more efficient, it's going to be really interesting to see how that kind of evolves and shifts. Something I'd love to ask you about is, what inspired you to co-create the Harvard X TinyML courses, and what impact do you hope that they are going to have?
Yeah, so basically, I should say that BJ is like the creator, so he should get all the credit. But
okay,
basically, it's just way more accessible than traditional machine learning, right? To do machine learning, you need a laptop at least, or you need access to these huge servers. And so a lot of the AI technology has been sort of kept in companies like Meta and Google, where they have all of the expertise, and it's not really been democratized in any way. And that's why like all of the frameworks are built by these few companies. But the cool thing about tiny machine learning itself is that, I can go and buy a $5 microcontroller and I can do something cool with it without necessarily having much expertise in anything. I can just learn it the same way I would a hobbyist project, like building a radio. I could just go and build an image classifier to detect like food waste, or, when someone's stealing my like beehives or whatever, if I'm a farmer. So there's really interesting use cases that you would just never consider or be able to do with traditional machine learning hardware. And then also, because you have access to these sensors, you just have a way larger array of use cases than you would have with the traditional types of data that you have with these systems. So it's usually pictures, right? Or audio data or textual data. But yeah, if you have sensor data of temperatures, CO2, inertial measurement units, so, like orientation, stuff like that, you can do some pretty interesting stuff with them that you couldn't do otherwise. And in terms of what we were hoping to get out of it, it's, democratization of this knowledge. We work for a university, so it's always nice to have greater outreach. And I think we had over 100,000 people take the course, and we were doing some we were doing some math on that. And we were like, well, you'd have to teach for like several hundred years to reach that many students. Just had a full class. So
that's amazing.
Yeah.
That's amazing, especially when like right now it's such a hot topic. So many people want that information. Yeah, just the traditional teaching method would have taken 100 years to actually get it done. So that's really incredible and super cool. It's nice to see you're already having a really big reach and a really big impact on that. Something else I'd love to ask you about is, as a research coordinator at ML Commons, what are some of the most pressing challenges you see in machine learning, especially, in the whole community and seeing that today?
Yeah, I guess there's a few. So, like generative AI is a huge thing right now. So I'd say that's something you hear a lot about. And ML Commons is known for benchmarking, right? It's like you take your system and you compare it to someone else's, and then you just, it's like the Olympics. You say who's better. But the thing is, how do you benchmark a generative AI model? What's the right thing to measure? The way that OpenAI has been doing it in the papers they publish is they say, oh, well, we did better than like 80% of the people that took the SAT. And so they're comparing it to like a human level, which is a really good thing to do. But then you miss out on a lot of other things like, okay, well, are the outputs like, are they biased in specific ways? Are they really good at some topics and not other topics? And so, if you measure one thing very specifically like that, you're automatically, and you use that as like the way to plug yourself forward. You're missing all of the other potential aspects. And because it's like so subjective for a language model or just a generative model in general, you get what you measure. If you measure SAT scores, you'll end up with a really good SAT solving language model, but it might be terrible or it might lie to you half the time.
Yeah.
So that's one aspect. Another one is compression of these models, right? So you've seen, we saw this like bifurcation of machine learning where you had, on a laptop or whatever, and then we start getting huge models where you can't even run it on one machine. You have to like do distributed training across 1,000 machines, and you have billions of parameters, and there's no way you could ever run that on like a normal machine. So massive models. And then we saw for tiny machine learning, you sort of go the other way and you go to sort of tinier models. And I think now the big model community has realized that's not the way to go because it costs so much to train these models. It uses so much, there's so many carbon emissions, and it's just it's not scalable much further. And you don't really get any benefits out of doing it. And so you've started to see people making slightly smaller models that perform just as well as the big ones. And so I think we've really seen the peak of the large language model when it would start to sort of become more efficient. So what people would start describing as like small, large language models. And you'll start seeing them being put on smartphones and stuff. But then you get into the challenge of, okay, well, how do I make it as good as ChatGPT, but it's on my smartphone or even on my smartwatch, things like that. So that's going to be really interesting to see how people deal with that. And then another big challenge that I'm seeing a lot of right now, just because I work in sensors, is that like when you start having all of these intelligent sensor systems around that have microphones and cameras on because they can connect to these models, there's a lot of privacy concerns that you get. And that could have, very far-reaching implications. So if you imagine in 5 years' time, you have a bunch of, like, let's say your toaster is smart and your microwave is smart, your TV is smart, and you go up to your toaster and you say, hey, can you make me some toast? And then all of a sudden, all of your devices turn on and they all have cameras on and they're looking at you. And if someone's hacked into you, that's a problem too. And you'd have things like gaze tracking, so your toaster will be able to look at you and say, oh, I know he's looking at me and not the microwave, so I should be the one that responds. But so it actually is pretty cool, that idea of these future systems, but just the privacy of, okay, someone's hacked into my Wi-Fi and now they can see me doing literally everything in my house. They could screw up my toaster so it like burns everything.
Yeah. That's crazy. And even I've seen some really interesting like AI models that like, yeah, well, it's kind of interesting. So there's that one side. At the same time, I feel like a lot of technology exists today that can do similar things. Like I've seen like an AI model that literally use like your Wi-Fi signal to like essentially get a 3D map of like your house and you, like it can see you as a person based off your Wi-Fi signals pinging off you, which is like crazy. But yeah, there's definitely like a lot of security and privacy concerns and things to be aware about, like with all of this integration. So I'm sure you're kind of at the forefront of seeing that play out and trying to solve some of those problems. Something I'd be curious to hear your perspective on is kind of the evolution of where this is going. Like, how do you really see the role of edge computing evolving in the context of, machine learning and AI? Where is this gonna go?
Yeah, so I'd say the biggest thing was just like, you had these dumb IoT devices where you could interface with the cloud. It's dumb because it's not doing anything itself. It's just like a portal to the cloud.
Yeah.
And then you add machine learning onto it, and it's like, okay, well, now I can do so many things. But there's still things that you can't do, For example, sensors tend to drift over time. And if you have a model that you trained 2 years ago, it's maybe not representative of what is happening now. And I think just recently, earlier this year, there was a paper that was released that showed you could actually do on-device training using less than 256 kilobytes of memory, which is insane. Like you need no memory to train a model continuously when it's not even connected to the internet. And so that means that you can actually just control sensor drift now. You could say, okay, I know my sensors are getting worse over time because of degradation or whatever. And that presents a lot of cool opportunities for, devices necessarily like, so I used to work in the Amazon. Let's imagine you put a bunch of devices in the middle of the Amazon. Clearly, you're not going to go there very often because it's a jungle. Mm-hmm. And so you want them to last a long time, and then you want them to also not drift. So in that kind of situation, you could deploy something and just have it run for a long time doing this machine learning without necessarily having to touch it. If you had enough batteries and solar power and stuff. So I'd say that's a super interesting development that I've seen just this year. Otherwise, though, honestly, it's not been super hot in this particular area recently. I think it's gotten sort of way more commercial of everyone trying to build cool devices like smart toasters and TVs and stuff. And the big problem is just like nobody knows. Like I remember the professor I worked with, VJ, the whole reason we started developing this new paradigm of sensing was that he bought this TV, and he was saying that one day he was doing yoga in his living room, and the TV said, "Hey, do you want us to analyze your yoga poses for you?" And he was like, "Oh, you need a camera to do pose estimation." And then he realized that there was a camera in his TV the whole time for 6 weeks since he got it, and he just never knew.
Really?
Yeah. And so we all sat there and laughed at him and said, "Oh, if a professor of edge computing doesn't know his TV has a camera in it, then we're all screwed."
Yeah, that's hilarious.
Yeah, so I'm definitely expecting. I don't know. I think it's one of the newer like smart TVs. But yeah, I definitely see that being a common problem in the next few years, and people being like, "Oh, maybe we should not do this, or at least like there should be a label that says there's a camera in my TV."
Right, disclaimers. That's really interesting. It's kind of funny though when you talk about all of those Internet of those IoT devices and stuff. It reminds me of the TV show Silicon Valley. If you've seen it, there's like a part where they pretty much like hacked into, or they got added to like this whole network of like smart fridges, and they essentially used it for like a lot of their processing. But it's kind of funny. It's making me think of how crazy it would be if you have all of these smart devices all around the world, and yeah, people somehow get like machine learning to be constantly running on those devices and training things over there and use them as like a decentralized network. Anyways,
some Bitcoin mining on your fridges.
Yeah, exactly. It'd be funny. I'm wondering, what are some of the more exciting use cases that you've seen that are kind of changing consumer behavior when it comes to natural language processing or other things?
Yeah, so, well, I mean, I don't work in industry, so it's hard to say, but I have seen some cool stuff recently. So I know that, at least I vaguely know that there's some like hedge funds and things that are basically trying to build language models they act as like an oracle for the stock market. So you can just ask it things like, oh, hey, here's an earnings report. What do you think is going to happen? So that's pretty cool. I'm sure you get paid a lot of money to develop that if you have enough skills. And then also I've seen the same thing for medicine. So, you really need to like fine tune this on huge amounts of patient data and stuff. So there's complications with that. But if you imagine going to the doctors and they just have a language model there that knows everything about you, and then you tell the doctor the symptoms and they're like, oh, well, I think you should do this, but let's see what ChatGPT also thinks. And then ChatGPT says, well, actually, you might have this rare thing. You should take this test. And then, that would be super cool if it worked. So I could definitely see some really specific use cases of language models generally in, especially in like scientific or just high tech areas, if you have enough high quality data. But that's the main concern. Yeah. Like, how do you get the high quality data? Because we've seen with language models, if they kind of train on their own outputs, you end up with this model collapse, basically, where it just starts giving you nonsensical outputs and stuff. So it's definitely very exciting. Another concern that I have with that is hallucinations, or I think some people call them confabulations now. But so just making stuff up, basically, like a human when they don't know what they're doing. But one thing I've seen which is super interesting, and I feel like it might actually go somewhere, is trying to connect language models to this thing called a knowledge graph. And so a knowledge graph is basically just like a large database which gives logical associations between different entities. So think of like Wikipedia as a good example. You say like, okay, there's this famous person, they were born on this day, blah, blah, blah. If you can somehow connect that to the language model to constrain it so that, when it makes stuff up, it can see if it's consistent with this knowledge graph. That could be a way of sort of making it make fewer things up, I would say. Right. So that's very cool. And then,
I think it's super.
I was going to say,
go for it.
Right now, the transformer model is like the basis of all language models. And just a few weeks ago, there was a paper that was published, which I'm a little bit skeptical of because I haven't really gone through it in full detail.
Okay.
But they propose basically a better architecture that is much cheaper to run inference on. And, that's maybe not the most interesting or exciting thing to say, but that would have huge implications in industry. If if you only need a fraction of the computing power to do an inference on a language model, you would save yourself maybe a factor of 10 in costs. And right now you're seeing this huge AI boom with chips. So it would definitely have some ramifications.
Yeah, it's really interesting. I've also heard from a lot of people kind of in the AI space, and there's a kind of this interesting concept that I've looked at recently, which is, of course, we have the transformer model right now, and this is kind of what everyone talks about, and it's like how we're building all these AI systems. And a lot of people are talking about a problem that we're getting into right now is, you have someone like OpenAI who gets $10 billion from Microsoft, and they're plugging this straight into the transformer model. They're like, there possibly are, because before transformers, there was other different avenues we were exploring for how to do some of the similar things with AI and how to achieve it. And they're saying, like, it's almost like vendor lock-in. Like we're putting so much money into this one method, which is kind of the transformer model, or just different ways that we do these. We put so much money into them once we find them, that sometimes when there's these, new technologies that potentially are better, people are just like, well, we've already spent like $1 billion on this. We're not even going to touch that. Like, we're just going to keep the idea this as good as we can get it. So I think that is an interesting thing, but it's really cool when you do see kind of these new shifts and people saying, hey, look, there's this completely new way to do it. And I think, at the end of the day, that problem is probably good because it leaves a little space for new companies, new upstarts, people that are willing to take risks to, have some sort of competitive edge to get into the market and try new things. But yeah, there's a lot less money that has already been poured into that specific use case or industry. Something I would love to ask you about, because you kind of touched on this some of the ethical considerations. Like, what are some things? I know you've kind of you have people in your lab. I know you probably don't work on like the autonomous vehicles as much and whatnot, but what are some ethical considerations that are kind of concerning or you think people should think about when it comes to AI? There's, facial recognition, autonomous vehicles, Internet of Things, there's all this different stuff. What are some of the ethical things we should be thinking about?
I'd say, actually, yeah, a good thing is probably security recently. Like, you probably heard about the MGM hacks, and you'd be like, oh, what does that have to do with any of this stuff? But if you go and speak to a cybersecurity expert, they'll just tell you that they're like scared terribly of IoT devices because, if you have 10 billion devices and they're just placed all around the place and they're all connected to your network, that's 10 million endpoints that a hacker can be like, oh, well, look at all these things I have to play with. And especially like, I remember speaking to someone that there's this conference called the Black Hat Conference in Vegas. And it's usually held at like the Luxor Casino. And I remember someone telling me that last year, the casino system got hacked through a thermometer in a fish tank, which sounds ridiculous, but they like took down the whole system just by hacking into this fish tank. And see, if you can do that and bring down an entire casino, your house is probably not safe if you have like if you have one of those electronic locks on your door. If someone has enough time and they really want to, like, they will definitely be able to break into that. And it's, you can spend infinite amounts of money on security, and you could still technically hack it. So it's just like, it's trade-offs, right? I'd say for most people, it's just not an issue, but I feel like the consumer sentiment is going to go towards, I want to make sure my devices are safe and they're not spying on me, and I can't just hack it by, going and downloading some random library like AirCrackNG and breaking into someone's Wi-Fi. So that's a huge one. And then also, I guess sustainability, that ties in with the vehicles as well. So I remember reading estimates in some paper that data centers are going to be about 10% of the carbon emissions by 2030, which doesn't sound like a lot, but compared to every industry in the world, that's pretty big. And those emissions didn't exist 10 years ago, so it's very easy for them to sort of balloon out of control without you thinking about them. And so now sustainable computing is like an actual research area where people are sort of making developments. Like, how do we make even things like language models more sustainable in terms of their training and deployment, and accelerators as well. So you might end up having the accelerators of the future not being the most power hungry and fast, but they're actually just the most energy efficient. So that will be an interesting development just to kind of see what happens. And with autonomous vehicles, you might find that if you start deploying thousands of them, they might offset their own emissions in some ways, because you'd have efficiency benefits in terms of like, it drives smoother than a person because, it knows when to brake just based on information from other cars around it.
Interesting.
And then also traffic optimizations. Like maybe your car will be like, I'm going to avoid this road because it's usually busy. And so you'd end up with less overall traffic and less idling. So that's that could be very interesting if it's deployed at scale, I think.
That's super, super cool. Yeah, and I think there's some really cool, exciting implications there. Matthew, it has been incredible to have you on the podcast today as we're wrapping up. For the last question, I'd love to ask you, pick your brain a little bit about what you're really excited about, what you're forecasting, some crazy things that you think we're going to see in the AI and in this space in the next like 5 to 10 years.
So definitely, I mean, we already talked about like generative AI, but definitely, I think everyone knows that's a game changer at this point. I've seen some really cool stuff with using it to create synthetic data. So I remember when GANs first came out. So GANs is just like two neural networks fighting against each other, basically, and one's trying to create like fake data, and one's trying to look at the data and say, hey, is it fake or not? But I've seen some really cool stuff where people have, made X-rays that look real to mimic specific diseases and stuff, because in the medical domain, it's really difficult to get access to data, because you need people's consent and stuff. So if you could just make data that is representative of what already exists, and you can bypass that. And you could imagine also doing this in terms of studies with chemicals that, they're under review by the FDA or whatever. you would need much fewer people to do the study if you could just take a few and then extrapolate it using synthetic data. So I think that'll be super cool. And then like we discussed with language models, putting them on your phones, putting them on your watches, basically everything, even like a toaster. Imagine if your toaster has a fine-tuned language model on it. That would be cool. And then one I think that's kind of slipped under the radar, I would say, is like virtual reality, AR. I think a lot of people think it's a gimmick. And right now, today, I'd say it's still a bit gimmicky. And the metaverse especially, I think that's a bit far up. But there's definitely like applications of it that I could see being used very widely. I've spoken to people about Google Glass, and a lot of people say like, "Oh, Google Glass, sucked, it failed." But actually, I think Google Glass,
you're ahead of their time.
Successful. Yeah, definitely. Yeah. Like it kickstarted this whole new field, and I'm surprised they haven't done anything since that. But I think the fact that both Meta and Apple are diving into this very deeply is a good indication that it's going to be pretty important. I mean, you have things like smart surgery. Imagine if you have a surgeon with glasses on who could see inside of your body using augmented reality. That probably would make them do a better job. I don't know. So yeah, that's super cool. And then obviously smart home is like we already kind of beat with a dead horse here.
Yeah, super, super cool. When you're talking about the synthetic data and stuff, it made me think of recently Amazon had this big problem where for their Amazon Go, right, that you go to the store, just grab what you want and leave. They're trying to build this whole concept, and they had this problem because they didn't want you to have to scan your phone. They just wanted you to just put your handprint when you walk into the store. But they're like, there is no centralized, there's no database of like, 1 million handprints for us to train this model off to tell if it's a human hand or a fake hand or whatever. So they literally created synthetic data. They created a database of over 1 million fake hands, and they trained the model off of that. And then it successfully works for actual people's hands because everyone's palm is different. And they're actually able to identify real human hands off the synthetic data, which is, really interesting because, you mentioned earlier the problem with like model collapse, or you kind of like train a model with its outputs and you have the collapse. So it's like in my brain, I'm like, like at what point is it kind of in that same direction? But it's really cool that we're able to do some of this really synthetic data stuff. And I think you're spot on when you predict this is going to be something really big moving forward. A lot of times people are like, how do we do X, Y, and Z? We don't have high quality data. It's like, we're going to generate the data and then we're going to train it. So it's really, really crazy where that all goes. Yeah. Matthew, thank you so much for coming on the podcast. Oh yeah.
Sorry, the hard part is the edge cases, right? It's very easy to get the middle of the bell curve, but it's hard to simulate the edge cases. So I think you might still have to have efforts to get those edge cases. So for example, with language models, one thing I've seen, I think Google was trying to do this, but if you have a generative output with images, for example, you'd have to have some kind of actor-critic model at the end of it to say, oh, what is acceptable and what is not acceptable. And for everything that's kind of like borderline, it uses that edge case, stores it somewhere, and uses that to train on, as like edge cases for training this model. And so that could be a cool way of using synthetic data to generate edge cases, or at least like constrain edge cases using this actor-critic model.
Very interesting. Very interesting. Yeah, that's super cool. Matthew, thank you so much for coming on the podcast today. Really appreciate all your insights, everything you shared and everything you're working on. It's awesome. I'm going to have get you back on here again. And as you continue to work on stuff, if people are interested in finding out a little bit more about what you're working on, getting in contact with you, what's the best way for them to go about doing that?
Yeah, so I have my website. It's mpstewart.io, and I think it has links to like my email and stuff. I'm pretty easy to find through Harvard's directory. So yeah, just shoot me an email if you have anything you want to ask me about. That
very cool. Okay, and I'll
obviously and stuff. So yeah.
Okay, sounds good. And I'll leave a link to your website in the description of this as well, so listeners can go find that. Thank you so much for coming on the show today. To the listener, thank you so much for tuning in to the AI Chat podcast. Make sure to rate us wherever you get your podcasts, and have a fantastic rest of your day.